The latest discoveries from the James Webb Space Telescope, JWST, may revolutionize our understanding of the universe. Currently, 6 strange light phenomena present an unsolvable puzzle to researchers. Initially, scientists believed these mysterious signals were galaxies, but doubts about this theory has since emerged. What, then, is the JWST really showing us? What exactly do we see at the edge of the observable universe? Could these light phenomena be traces of another dimension, hinting that our world is vastly different from what we thought? Could they even provide the first real evidence that our universe is one of many? Have you ever gazed up at the night sky and wondered what you were really seeing? You might quickly say, "Stars," but that's only part of the truth. Yes, the night sky is dotted with the light of thousands of stars, but it also contains galaxies, bright planets like Venus or Jupiter, and, of course, our moon. However, what you're really seeing goes much deeper. You're looking into the depths of the universe, and more fascinatingly, you are looking into the past. None of the stars you see in the night sky exist in the places you perceive them. They've long since moved on, but their light continues to travel toward us. This light could take years, millions, or even billions of years to reach Earth. For instance, 2 stars that appear to be neighbors in the night sky might not be close at all. One could be a dim, nearby star, while the other is hundreds of light years away but appears close due to its brightness. This creates an illusion, much like observing an island archipelago from a distance. From afar, the islands seem to be closely strung together, but as you approach, the true vast distances between them become clear. Understanding this perspective adds a layer of depth to your stargazing. You're not just seeing points of light in a 2-dimensional space, but rather looking into a complex 3-dimensional universe where time and distance distort reality. However, you must remember that what you're seeing is still just light from the past, not the reality of the present. The JWST's infrared technology has pushed the boundaries of our understanding, revealing details we never thought possible. This telescope can detect light so fine and thin that human eyes would never be able to perceive it. However, even the JWST is bound by the laws of physics. Just like our eyes, it can only record light that has traveled through space for a long time. In other words, the JWST, too, captures images of the past. The very first image published by NASA in the summer of 2022 was a deep-field image of the universe. The telescope focused on an almost empty area of the sky for hours, gathering faint light traces from the background. If we were to look at this region with our naked eyes, we'd probably see nothing but a dark void. Yet, in the absence of foreground interference, the oldest objects in the background became visible. The orange and reddish light sources visible in that deep field image are the oldest objects observed. Their reddish color is due to an effect called redshift. As light travels through space, the expansion of the universe stretches its wavelength, shifting it toward the red end of the spectrum. This redshift also helps scientists determine how far away an object is and how long its light has been traveling toward us. One of the light sources captured by the JWST has a redshift of Z equals 11, meaning it's 13.5 billion years old. This object existed just 300 million years after the Big Bang, yet it appears to be a massive, well-developed galaxy, something that shouldn't have existed at such an early stage of the universe. According to current cosmological models, the universe at this time should have only had its first stars and loosely formed groups of stars. Shortly afterward, another galaxy was found, even closer to the Big Bang, at Z equals 13, only 200 million years after the universe's birth. These discoveries are causing scientists to rethink what they know about galaxy formation in the early universe. More galaxies emerged in subsequent months, leading to more surprises. 6 new galaxy candidates made headlines, but they couldn't be fully confirmed. Researchers now question whether these light sources are galaxies at all. If they aren't galaxies, what could they be? There are many questions about the true nature of these light sources, leading some to speculate about a parallel universe or a mirror dimension. It's a fact that we don't know how big the universe is or whether it has a boundary. We can observe up to 46.5 billion light-years in each direction, creating a view of a space roughly 93 billion light-years across, but no edge has been detected. All of our theories about the universe's boundaries or beginnings are, at their core, speculations. The Big Bang Theory, which posits a temporal beginning to the universe, has provided a framework for understanding cosmic history, but even it is just a theory, backed by mathematical and physical models without definitive proof. Many hoped that the JWST would capture the universe's first light sources, giving us direct evidence of its early stages. However, instead of chaotic star clusters and nascent galaxies, the JWST revealed perfect, ancient-looking galaxies, something no one expected. These findings have left the scientific community abuzz. Some are questioning the Big Bang Theory itself, suggesting instead that galaxies formed much more quickly than previously believed. Others are proposing new calculations for the age of the universe. Quantum physics also provides fascinating possibilities. The idea of a multiverse, with other dimensions and variable realities, has long been discussed in quantum circles. Could it be that these perfectly formed galaxies aren't from the beginning of our universe, but from a mirror dimension? This fantastical idea gained traction when researchers discovered Schrödinger's galaxy, also known as CERS 1749. This galaxy seems to exist in two places and at two different times simultaneously, a phenomenon eerily reminiscent of quantum mechanics, where particles can exist in superposition until measured. In addition to these galactic puzzles, the JWST also detected light sources that could potentially be gigantic quasars, shining brightly at the beginning of time. Quasars are active galactic nuclei containing supermassive black holes. The immense gravitational forces in these black holes heat the surrounding matter to such an extent that they outshine entire galaxies. Could these mysterious light sources be quasars, rather than galaxies? While this theory could explain the observed light, there remains a fundamental problem. Even quasars of this magnitude shouldn't have existed in the early universe. The early universe, according to the current cosmological model, didn't have enough time to form such massive objects so soon after the Big Bang. The JWST's remarkable observations are pushing us into uncharted scientific territory. The telescope's ability to break down light signals into individual frequencies allows researchers to gain a wealth of information about the universe. By analyzing the intensity of light, the presence of various elements, and other crucial details, we can learn more than ever about the objects emitting this light. However, even with its ultrafine spectrometers, the JWST cannot fully resolve these mysteries. For example, we still can't say for certain whether these objects are galaxies or something else entirely. The information provided by the JWST suggests that they could be black holes, quasars, or even something we've never seen before. What is clear, though, is that these discoveries are challenging our understanding of the universe's beginnings. Could these light phenomena be evidence of an entirely new understanding of the cosmos? Could they hint at a multiverse, mirror dimensions, or realities that coexist alongside our own? While it's too soon to draw definitive conclusions, one thing is certain. The James Webb Space Telescope is opening the door to questions that could fundamentally reshape our understanding of the universe. As the scientific community grapples with the mind-boggling implications of the JWST's discoveries, the challenge lies in proving what these light phenomena truly represent. When researchers initially detected the 6 strange light sources, many believed they were simply ancient galaxies, albeit far older and larger than what current models would allow. Yet, as deeper analysis unfolded, cracks began to form in that theory. Galaxies take time to form. They start as clusters of stars, eventually growing through interactions with other galaxies, mergers, and accretion of matter. The early universe, just a few 100 million years after the Big Bang, should not have had galaxies as large or as luminous as those detected by the JWST. If these objects are truly galaxies, then their size and level of development throw everything we know about the timeline of cosmic formation into question. The James Webb Space Telescope has revealed strange light phenomena that challenge our understanding of the universe. These discoveries could rewrite the Big Bang Theory, hint at the existence of a multiverse, or reveal unknown dimensions. As we continue to explore these mysteries, one thing is certain: our universe is far more complex than we ever imagined. Stay tuned for more groundbreaking discoveries.